component testing versus unit testing. In software development, we write tests to assert that our code works as expected. However, we can write tests at multiple levels. We can check that a specific function works as expected. Let's say it's an independent function, a function that does not call other functions in our code base, but only library functions. We can check that multiple classes behave together, so we would call the entry point of a function which involves multiple classes in the test. We can check that our whole service works as expected without starting the service. So if our service has some entry point, we would test this entry point. And then we can check that our service works well with tests when it's calling other services. So in this case, we would have the service actually up and run a few functions against it. And then we can go to a higher and higher levels of testing, and eventually we'll test the whole system, and then we can test multiple companies, and then we can test the whole world, and then the whole universe. So we are going upward. The thing is that it's very easy to test a very specific function which does not call other functions. But the problem is that we have many functions. So if we decide to go with testing specific functions on the lower level, then we'll end up with a huge amount of tests that test very low functionality. And when we test a function that does call other functions, then in this method of pure unit test, we would mock other function calls. So we would mock the return type of our other functions so that our test tests only the specifics of the function that we actually test, only its logic. This is unit testing. And there is a famous triangle of testing that shows that unit tests are at the bottom, and then as you go higher, the triangles get more sharp, and at the top layer you have the integration or the end-to-end tests, which should be few because they are more flaky. It depends on, it has many dependencies, many services, latencies, configurations, deployments. It has many dependencies, and if you test on an end-to-end and exactly at this time the server is blurping, that then this test would fail. This is the flakiness. So this is why the triangle of test shows that the unit tests at the bottom are and should be the ones which are the most in our system. But still, when you try to create so many unit tests, and you see that there are so many, and it actually doesn't give me a good feeling of whether the system is behaving well or not. I added 1,000 tests. Let's say we added 1,000 tests to many sporadic functions, but do we actually have good cover? Was it worth the effort of writing so many low-level tests? And this is where component tests come into place. So what we are suggesting here is that we don't focus on unit tests. Unit tests should not be at the lower side of the triangle. We could even skip them completely. 0 unit tests. We want to write unit tests, but for functions which have complexity. If the function is a complex algorithm that you want specifically to test it, unit tests sound like a good case. But let me ask you this. If you have a getter, do you write unit tests? No. So getter is one extreme, and an algorithmic function is another extreme. But there is balance. So we suggest that you should not write unit tests. You should not write unit tests, except for algorithmic functions, except for something which is complex. And then we should ask ourselves, Why is it complex? Could we make it not complex? But let's say that it's a given. It's a complex function. Maybe we're manipulating some existing code, some maintenance of existing code, and because we do this maintenance, we are changing a specific function, and we want to write unit test to it. Sounds like a good use case for unit test. But if you're writing a service, and today we live in a extreme microservices world, so you have a service which is responsible for some functionality, and now you want to check it. What is the best way? Unit test? So we say that no. What you should do is get to the entry point of the server, the service, and while the service is down, it should not be up, because we want also the stability. We want to get basically the two edges. We want both to get full coverage of our service, and we don't want to write a huge amount of unit tests for each and every function. So we forget completely about unit tests, and what we do is write all the tests against the entry point of the service. And this way we can get full coverage, be sure that our service behaves as expected, and it's going to be easy to change the flows, because the tests that we are giving it with the input that the user is entering to the service. So lo and behold and welcome the component test. This is what we call the component test, testing a full component while the server is down. And only when we really need to get into higher levels, only then we write integration and system test and end-to-end, but they are much more flaky. So over there we just want to cover some basic flows. If we have 5 main flows in our system, then these are going to be the 5 main flows. So this was a brief overview of why we should prefer component test to unit test. When could unit test be useful? I didn't mention also that unit test can cause you to think about the function name, because once you write the unit test, you use the function name that you're calling. So you're saying, oh, this is a strange function name. But I don't think it's worth the effort. Just we can write this unit test, and then I would just write the unit test, think about a better function name, and then delete this unit test. It's useless. And this was our brief overview in between component test and unit test. I hope you enjoyed it, and see you next time.